Hello and welcome to another video. In this video we're going to be working on minimize maximum pair sum in an array. And in this problem, the pair sum of a pair is equal to a plus b, and the maximum pair is the largest pair of all the elements of all the listed pairs. And you're trying to basically minimize the maximum pair in this list. So you have to pair up every two elements, and you're trying to pair it up in a way where the maximum pair is minimized. So for example here, they pair 3 and 3 and 5 and 2, so you get 7. Second example, pair 3 and 5, 4 and 4, and 6 and 2, so the maximum pair is 8. And so when we figure out what algorithm to use for this problem, like obviously it sounds pretty easy, but let's kind of go through the process. So first thing, we're going to look through the constraints. So n is 10 to the 5th. That means that we can't have like a backtracking or brute force or anything, right? We have to have an n log n solution or better, or a two-dimensional solution, but the second dimension has to be pretty small. Because n squared would fail, because I don't think on LeetCode like 10 to the 9th or 10 to the 8th or something fails. So anything above that would fail. So we are left with something like some kind of DP where our second dimension is small, maybe like a 2-pointer, heap, binary search, things like that, right? And so when we also look, we are trying to maximize something. So typically when we try to maximize something, DP is pretty common. But like I said, it's kind of hard to figure out like what's another dimension. Like we'd have to have an index for both the pairs or something. And that's kind of difficult. Like it's going to be very hard to have like a one-dimensional. So DP is like probably not it. Now as far as heap and binary search, so you could try to figure out like, you could have one thing and you could try to like figure out, like let's say I take this number and I figure out like what's the best pair for this. Is there any way to binary search or heap? Well, let's just think about our sorting, or not our sorting, our actual pairs. Like what makes sense to do with the pairs. So if, let's say I have the biggest numbers, right? Let's say I have a bunch of numbers like A, B, C, D. Each is greater than the next. So for the biggest number, how would I want to maximize, like minimize the pair there? Well, I'd probably want to get the biggest number and add it to the smallest number, right? Pair those up, and then get the second biggest number and pair it up with the second smallest number, and so on. So that would ensure my pairs are, you know, small or as small as it can be. So it's kind of like a greedy 2-pointer approach. And now we basically have to figure out like, is there anything wrong with that? Well, all we have to do is keep track of like the biggest pair, right? We don't care about every pair we have. We just need to maximize or minimize the biggest pair. So we can just keep track of the biggest pair and things we used. So what we could do is we could do something like I said, we can't really do DP, so we can kind of do like a 2-pointer. But the 2-pointer, the way we're going to do it is we're going to sort the array first, and that's fine because we can have an n log n solution. So we're going to sort, and then we're just going to have a 2-pointer from the start and the end, right? So if we have a bunch of numbers, like let's just say we have something like this. So we have 5, 6. Let's say we have 1, 2, 3, 4, 5, 6, 7, 8 numbers. And then we can just say like, okay, well, let's just pair the biggest element with the smallest. And let's move the pointers in, then let's pair the next two, and let's pair the next two, and let's pair the next two. Because if we're concerned with minimizing, then if we pair the 8 with anything but a 1, we'll have a worse result, right? So it turns out like and basically this is kind of like the greedy-ish, where at every single number we just do like what's best now, and then for greedy you basically have to check like, did what I do kind of work out? And so it does work out for this problem, where essentially whatever number you have, you start from the end, you just pair it with the smallest one you have available. So we literally just have a left pointer and a right pointer, we pair them together, and then we move them in. And we can just keep track of like the biggest pair, right, with some variable like result, and we'll just try to maximize. We're not going to, actually we are going to maximize the result. We'll just keep all the pairs, and then whenever we have a pair bigger than our older one, all we have to do is keep the maximum pair. And that's basically it. So essentially we're going to sort and then have this left and right pointer and pair things up like this. So 1 and 8, 2 and 7, 3 and 6, and so on. And you can kind of get a little intuition from these problems. But so we did eliminate a lot of things from the constraints, right? Because if it was like, you know, let's say 20, then maybe we could just do like a brute force, right? Or something like that. But because the number's big, we know that we can eliminate some things like DP, you know, and things like that. So yeah, and then another common one for a big size is like sliding window, but obviously we can't really do a sliding window because we're trying to, like, if our goal is to pair things with the biggest and the smallest, it's not really a sliding window, it's more of like a two-pointer. But two-pointer and sliding window are also very similar, right? So there is another solution here that's actually an O of n solution, but I think in the general case it's going to be worse. And the idea of this is kind of like we did in the problems in the past, recent few days, is instead of sorting, you can, because num's I is 1 to 10 to the 5th, we can instead record every single number and the count of it that we have in the array. So like for 3523, for example, I'll just briefly talk about this one. We're not going to code this up because in general, it's going to be worse. So for 3523, we're going to say like, we're just going to go through this and we'll say like 2 has a count of 1, 3 has a count of 2, and 5 has a count of 1. And then maybe we can also record like the biggest and smallest number we found. And we're basically going to loop starting at the bottom and the top, right? So we'll say like, okay, well, let's just keep looping until we have numbers. Smallest number is 2 and the biggest number is 5. Let's take those counts, and then depending on those counts, we can make a pair, right? So we'll say like, okay, 2 and 5 can make a pair, and then we basically can't sort, so we don't know like what other numbers we have. So then what would happen is when we make a pair here, then we'd have to manually like try other numbers. Like we'd have to get the smallest number and manually try like, oh, is 3 in here? Yes, it is. Okay. And for the biggest number, is 3 in here? Yes, it is. But this is going to be really bad, really fast. Like let's say your numbers are like 1 to 100 and then like 10 to the 5th or something, then this is going to get really bad really fast, right? Because 1 will have 1, 2 will have 1, 100 will have 1, and 10 to the 5th will have 1. And basically the problem here is you don't really know what number comes next. Or, yeah, you don't really know what number comes next. Like you can keep track of the keys, but the problem is you can't keep track of the keys in a sorted order, right? Because your array is not going to be sorted to begin with. So you basically have to manually, like once you use up this 1 and 10 to the 5th, because you kept track of those as your bounds, you don't really know what the other numbers are in here because they're not in a sorted order. Like it could be like this, or it could be 102. So you can't just loop through the keys in some order, right? So basically what you're going to have to do is you're going to have to manually go up like one number at a time and go down one number at a time until you hit the numbers you're looking for. And as you can see, this is only an array of length 4, but it's going to get very expensive because you're going to have to manually like go down 10 to the 5th minus 1, minus 2, minus 3, and until you get to this. So that is technically an n plus m solution where n is the length of the array and m is the constraints of the problem, like the biggest and the smallest number. It's going to be like biggest minus smallest number. So for some specific cases, like imagine your array is 10 to the 5th long and has almost every number. For those cases, it would basically be an O of n solution. But for anything else, it can get really bad. So that's why we're not going to code up this one. We're just going to do the sorting one. Also, the sorting one is obviously a lot more straightforward. So let's do that. So first, we're going to sort our numbers. Then we're going to have a left and a right. And it's just going to be 0 and length nums minus 1, right? The first and the last number. And we'll have a result. So we can call this like biggest pair or something, right? Instead of using result all the time. Okay. So biggest pair. And now we can just say like while left is less than right, biggest pair equals max of biggest pair. And nums right plus nums left. And then we will decrement, or we'll increment left, and we'll decrement right. So we're going to get every single pair, keep track of the biggest one, and return the biggest pair. And that should do it. So let's see. Okay, and we have a solution that works, and it's pretty good. Okay, so let's talk about the time and space for this one. So essentially, for the time and space, so for the time, it's n log n, right? Because we are sorting. And for the space, it's going to be O of 1 because we don't need any other like data structures or anything. We just have a left and a right pointer. And yeah, I think that's going to be pretty much it for this one. Pretty easy problem, honestly. For a medium problem, it's kind of closer to an easy problem, as long as you can realize the best way to make the pairs, where you just pair the biggest numbers with the smallest ones. And yeah, it's going to be it for this one. Hopefully you liked it. And if you did, then please like the video and subscribe to our channel. And I'll see you in the next one. Thanks for watching.